explosive science, and epic stories. Deep beneath your feet, right now, there's a hidden world of fire, pressure, and raw power. A place where the Earth itself breathes, rumbles, and sometimes explodes. Welcome to the heart of a volcano, a place so wild, so untamed, it's like stepping onto an alien planet. But what's really inside a volcano? How does a mountain turn into a ticking time bomb? And how do scientists stare into the jaws of these fiery giants to predict when they'll erupt? Buckle up, because today we're diving into the science, the stories, and the jaw-dropping secrets of volcanoes. This is going to be a ride you won't forget. I'm Mark, and this is What's Inside a Volcano? The Science of Eruptions. Hit that subscribe button, grab some popcorn, and let's journey to the molten core of our planet. Trust me, you're not ready for this. May 18th, 1980, a quiet Sunday morning in Washington State. Families are having breakfast, kids are playing outside, and Mount St. Helens, a snow-capped beauty, looms in the distance. For months, it's been rumbling, spitting steam, giving little warning signs. Scientists are watching, but no one's really ready. Then, at 8:32 a.m., the mountain explodes. In seconds, the entire north face of the mountain collapses. A blast of superheated gas and ash screams across the landscape at 300 miles per hour, flattening forests like toothpicks. 57 people lose their lives. Towns are buried in ash. The sky turns black. This wasn't just an eruption, it was a wake-up call. Volcanoes aren't just postcard-perfect mountains. They're alive, unpredictable, and they hold secrets we're only beginning to understand. This chunk of rock, it's a piece of a volcano's story, light as a feather, but born in fire. To understand what's inside a volcano, we need to go deeper, literally. Let's start with the basics. What is a volcano, and why does it go boom? Picture a volcano like a pressure cooker buried inside the earth. At its heart is the magma chamber, a massive underground pool of molten rock, magma, that's hotter than 1,000 suns, reaching temperatures up to 2,200 degrees C. This magma is the lifeblood of the volcano. But it's not just sitting there. It's under insane pressure, pushing, bubbling, and waiting for a chance to escape. Magma isn't just liquid rock. It's packed with gases, water vapor, carbon dioxide, sulfur dioxide, like the fizz in a soda can. Shake that can too much, and pop. That's what happens in a volcano. The gases want out, and when they find a weak spot in the Earth's crust, they blast through, creating the volcano's vent, the pipe to the surface. But here's the cool part. Not all volcanoes are the same. You've got the classic cone-shaped stratovolcanoes, like Mount Fuji or Vesuvius, built from layers of lava and ash. Then there are shield volcanoes, like Hawaii's Mauna Loa, wide and gentle, oozing lava like a slow-motion river. And don't forget calderas, giant craters formed when a volcano erupts so violently it collapses into itself, like Yellowstone. Each one's a unique beast, shaped by its magma, its location, and its mood. So what makes a volcano erupt? It's all about pressure, chemistry, and timing. Let's dive into the science that turns a sleeping giant into a fire-breathing monster. Eruptions are like the Earth throwing a tantrum, and it all starts with the magma's chemistry. Magma comes in different flavors, from runny and chill to thick and explosive. The key player? Silica. The more silica in the magma, the stickier it gets, trapping those gases like a cork in a champagne bottle. Runny magma, like in Hawaii, lets gases escape easily, so you get those mesmerizing lava flows. But sticky magma, like in Mount St. Helens, holds the gases in until the pressure is too much. Then, kaboom! You get an explosive eruption, hurling ash, rocks, and gas miles into the sky. But it's not just the magma. The Earth's tectonic plates are the puppet masters. Volcanoes form where plates collide, pull apart, or slide past each other, creating weak spots for magma to rise. Think of the Ring of Fire, a horseshoe of volcanoes wrapping around the Pacific Ocean, home to 75% of the world's active volcanoes. It's like the Earth's danger zone. And then there's the wild card, water. When magma meets groundwater or seawater, it's like throwing water on a grease fire. The water flashes to steam, adding even more pressure. That's why some of the deadliest eruptions, like Krakatoa in 1883, happen near the ocean. So we've got magma, gases, plates, and water all conspiring to make a volcano erupt. But here's the million-dollar question. Can we predict when it's gonna happen? Let's meet the volcano hunters who risk it all to find out. Meet the volcano hunters, geologists, seismologists, and tech wizards who treat volcanoes like a giant puzzle. Their mission? To figure out when a volcano's about to blow, so people can get out of the way. But it's not easy. Volcanoes are sneaky, and they don't follow a schedule. Scientists use a toolbox of high-tech tricks. Seismometers listen for tiny earthquakes, rumbles that happen when magma moves underground. Tilt meters measure if the volcano is swelling like a balloon about to pop. Gas sensors sniff out sulfur dioxide and other gases leaking from the magma. And satellites? They're like the volcano's babysitter, watching from space for heat, ash, or ground movement. But here's the catch. Volcanoes are unpredictable. Take Vesuvius in 79 AD. It buried Pompeii in ash and pumice, catching everyone off guard. Today, scientists are better equipped, but it's still a game of educated guesses. For example, before Mount Pinatubo erupted in 1991, scientists noticed a spike in earthquakes and gas emissions. They warned the government, and tens of thousands of people were evacuated. That's the power of science saving lives. But not every volcano plays nice. Some, like Yellowstone's supervolcano, are so massive that predicting an eruption is like predicting the weather a year from now. Speaking of supervolcanoes, let's talk about the big bad ones that could change the world. Yellowstone isn't just a national park, it's a supervolcano, sitting on a magma chamber so big it could fill the Grand Canyon 11 times. If it erupted, it wouldn't just be a local disaster. It could alter the planet's climate, block out the sun, and disrupt food supplies for years. Thankfully, supervolcanoes erupt rarely, think every 600,000 years or so. Yellowstone's last big one was 640,000 years ago, so we're probably safe for now. But scientists keep a close eye on it, because even a small eruption could cause chaos. Fun fact, Yellowstone's magma chamber powers its geysers, like Old Faithful. So every time you see a geyser, you're seeing the volcano's heartbeat. Supervolcanoes remind us how powerful the Earth is. But they're not the only volcanic threats. Let's travel back in time to meet some of history's most epic eruptions and the people who faced them. Pompeii, 79 AD. Mount Vesuvius erupts without warning, burying the city in 20 feet of ash. Thousands perish, but the ash preserves their homes, their food, even their bodies, giving us a haunting snapshot of Roman life. It's a tragedy, but also a time capsule. Fast forward to 1815. Mount Tambora in Indonesia unleashes the largest eruption in recorded history. The blast is so powerful, it's heard 600 miles away. Ash and gas block the sun, causing the year without a summer. Crops fail, people starve, and the world learns just how far a volcano's reach can go. And then there's Krakatoa, 1883. Its eruption was so loud, it ruptured eardrums 40 miles away and sent tsunamis racing across the Indian Ocean. The skies glowed red for months, inspiring artists like Edvard Munch. Volcanoes don't just shape the land, they shape our history, our art, even our fears. These stories show us volcanoes are more than science. They're human drama, but they also create beauty. Let's explore how volcanoes shape our world in ways you'd never expect. Volcanoes destroy, but they also create. Every lava flow builds new land. Hawaii's islands, born from volcanic eruptions over millions of years. Iceland, a volcanic hotspot that's still growing. Even the soil around volcanoes is super fertile, feeding crops that sustain millions. And let's talk about gems. Volcanoes give us diamonds, emeralds, and obsidian. Black volcanic glass, sharper than a scalpel. They also create hot springs, where people soak in mineral-rich waters. Volcanoes are the Earth's artists, sculpting landscapes and treasures. But the beauty comes with a catch. Living near a volcano is a gamble. So why do people do it? Let's meet the communities who call volcanoes home. Mount Etna, Sicily. It's one of the world's most active volcanoes, erupting almost every year. Yet people live right on its slopes, growing grapes for world-famous wine and building homes from its lava rock. Why? Because volcanoes give as much as they take. In Japan, Mount Fuji is a spiritual icon. People climb it, pray to it, and live in its shadow, even though it's still active. In Indonesia, millions live near volcanoes, farming rice in rich volcanic soil. These communities don't just survive, they thrive, blending science, tradition, and courage. But living with volcanoes means being ready. Evacuation drills, early warning systems, and community resilience are key. It's a dance with danger, and these people are masters of the steps. Host. So what's next for volcanoes? As our planet changes, so do they. Let's look at the future and what volcanoes might have in store. Climate change is shaking things up for volcanoes. Melting glaciers reduce pressure on magma chambers, potentially triggering eruptions. Rising sea levels could make coastal volcanoes more explosive. It's a feedback loop we're just starting to understand. But technology is our ace in the hole. AI is crunching seismic data to predict eruptions faster. Drones are flying into craters to collect samples, and global networks of scientists are sharing data like never before. We're getting better at reading the Earth's pulse. Still, volcanoes will always surprise us. They're a reminder that we're guests on this planet, not the bosses, and that's what makes them so fascinating. Volcanoes aren't just science or history, they're a mirror. They show us the Earth's power, its beauty, and its unpredictability. They teach us humility, resilience, and wonder. Whether it's a farmer planting in volcanic soil, a scientist decoding seismic waves, or an artist painting a fiery sunset, volcanoes connect us all. And here's the crazy part. We're all shaped by volcanoes. The air you breathe, the land you walk on, even the phone in your hand, it all traces back to the Earth's fiery heart. Volcanoes aren't just out there, they're in us. So the next time you see a mountain, a geyser, or even a news alert about an eruption, remember, you're witnessing the Earth's story, a story of fire, creation, and survival, and it's still being written. Wow, what a journey! From magma chambers to supervolcanoes, from ancient Pompeii to cutting-edge science, we've uncovered the secrets inside a volcano. But there's so much more to explore. What's your favorite volcano? Have you ever visited one? Drop a comment below and let's keep the conversation erupting. If you love this deep dive, smash that like button, share this video with your friends, and subscribe for more epic adventures into the wildest corners of our planet. Hit the bell so you never miss an eruption. Until next time, stay curious, stay bold, and keep exploring. I'm your name, and I'll see you in the next one.